We'll finish up with a few welds that are neither fillets nor grooves, and then we'll go on and look at some extra symbols which you can add to your drawing. Plug welds, I think we mentioned them in passing before. A plug weld has a hole in one of the plates, a circular hole, and essentially it's a fillet weld around the inside of that hole. A slot weld is just a plug weld with a slot instead of a circular hole. So they're both the same kind of thing. One has a circular hole and one has a slot hole. This picture at the bottom is from the AISC Steel Detailing Manual. Now the interesting thing about plug welds and their cousin the slot weld. You don't have to tell the welder anything. You are leaving almost all the decisions up to the expertise of the welder. So you tell them you want a plug weld around here. You do not tell them what size to make the hole, and according to the standard, you do not even dimension the hole or where it's located. You just say, I want some in here, and the welder knows what to do. Another kind of weld that you run into is the backing weld. So here in this middle picture you can kind of get a sense of what this is for. If you have a real thick piece of metal and you're doing a groove weld in here, chances are good that everything's going to get real hot and that liquid weld material is just going to run out the back side and you won't have a weld. So what you do, or what they do, is they put a weld on the back side before they come in from the front side. It's called a backing weld. It's kind of like a lid or putting a bottom on the box. And that it's the same material as the other weld material, so it has the same melt temperature. So it doesn't melt through, and it provides a container for all the material in the groove weld. Now, and see what that symbol looks like. It's a bump. It's a bump on top of the leader line. Well, you can also use that bump on top of the leader line or under the leader line to indicate surfacing. Here's an example. This is a steel plate that goes over a utility access place in the street down in Los Angeles. It's a fairly thick plate. And the fabricator who made this plate clearly had a robotic welder and used surface welding to make a grid shape of bumpy raised weld stuff to make a non-slip surface for pedestrians to walk on. And I will just say that the number of combinations you can consider is nearly limitless. Sometimes, in fact, designers sometimes crack jokes about how people will get carried away with putting all these stacks of symbols together. Really, it's limitless. We try not to do this because really we want to be clear. That's our job. Now let's look at supplemental symbols. We already have talked about arrow side and far side and both sides. Item D here is the all-around symbol, and the all-around symbol is important. You use it a lot. You use it to indicate welding all around, and you'll use it other places in drafting to indicate something about all around. Could be a surface finish all around, or a geometric tolerance profile that's all around, or who knows. That's a common universal symbol for doing something all around. The field weld symbol is a flag, and you're not likely to run into that symbol with a mechanical drawing. Now, if you are working for a company that's going to install industrial equipment at the customer's job site and you want your applications person to wait and weld something on at the job site, you would use that symbol. It's just not as common as in something like structural steel. Then these three symbols at the bottom indicate what shape the surface is going to be. If you want the weld to be flush, to be flat, you use a flat line, and the flat line, as we'll see in some examples, is either parallel to the fillet thing, or it's directly above or below the bevel or V-groove thing. So that's flush, that's flat. You can ask to have a weld surface be convex, sticking out, or you can ask it to be concave, dipping down a little. Here's an example from AWS. If you want a fillet weld to look like this picture on the right, you want a fillet weld, but then you want someone to come along and grind it so it's flat for whatever reason. The way you indicate that is with, first of all, the straight line, and notice how the straight line is parallel to the slope of the fillet symbol. And then you put a G next to it, which stands for grind. Now, I grant you that in the world of mechanical drafting, when we look at ASME fundamental rules of dimensioning, there is a rule which says we are not supposed to specify the manufacturing process. In welding, it's a little bit different. Grinding will give a smoother finish than, say, chipping using one of those hammery things, and not as smooth as machining. So in a way, you're kind of telling them what surface finish you want in a real rough sort of way. This is AWS. Looking at the top example, here is a V-weld where the designer wants it flush with the base metal, and so that's indicated with the V-groove symbol and a horizontal straight line under it. The one in the middle is a J-groove, and one side is going to be bumpy, that's fine, it won't show. The other side is supposed to be flat, but not real precisely so. The extra stuff sticking up will be removed by chipping. And so that's indicated with a straight line and a letter C outside of it, meaning chip. If you want the weld to be convex, and sometimes you do just for additional reinforcement, you put the convex surface shape symbol so that the convex shape points outward. And what I'm trying to get at is this double bevel groove symbol here, notice, has a convex thing pointing up on the top and a convex thing pointing down on the bottom. And then it says, achieve that by grinding. So don't just leave it lumpy, come along and grind it. These are some examples out of our book. They're kind of fuzzy. What can we pick out? Number 4 is an example of an all-around. So here's some kind of round thing with a fillet going all the way around. Number 5 is an example of a flat finish. It's not indicated whether it's ground or chipped or machined. It's just flat. Number 6 shows a concave contour. Once in a while you want those. And they're supposed to achieve that by grinding.